talking about solving systems of linear inequalities. And you've already seen systems of 2 inequalities, and today we're going to be looking at systems with 3 inequalities. And if we look at this, we have to remember how to graph in y equals mx plus b format. We have to remember that m is our slope and b is our y-intercept. And that when we graph in slope-intercept form, we graph our y-intercept first and then our slope. Also with linear inequalities, if we have the less than or greater than symbol, our line is going to be dashed. And if we have a less than or equal to or greater than or equal to symbol, our line is going to be solid. Okay, so let's look at the very first one. The y is less than 3x minus 2. So we're going to graph this like we normally do in slope-intercept form. Our intercept is a -2. And then we're going to graph our slope, which is 3, which is a rise 3, run 1. So 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And then we can go the opposite direction. Okay, and then since it's less than, we are going to have a dashed line. And now the next piece we have to do is we have to test a point to see where we're going to shade. The easiest point to test is 0, 0, unless your line is actually going through the origin, but this one isn't. So we're going to test 0, 0. So we're going to plug in 0, 0 for x and y. And we're going to see if this is a solution. And we're going to see if it's a true or false statement. Now, is 0 less than -2? Now, this is not a true statement. So that means 0, 0 is not a solution, so we cannot shade on the side of 0, 0. We shade in the opposite side of that line. Okay, let's do the next one. Y is greater than -x plus 4, so our y-intercept is at 4. And we have a negative slope of 1. And since it is greater than, then we are going to make a dashed line again. And yours will be much nicer and neater because you'll use a ruler. Okay, and now we're going to test the point 0, 0 to see where we're going to shade. So we're going to plug in 0 for x and y. Now, is 0 greater than 4? No. So that is not a solution, so we cannot shade in the direction of the 0, 0. So we're going to shade on the opposite side of that line. All right, let's do the very last one. Y is less than or equal to 2. Remember, a line with a y in it is a horizontal line, and that's going to be at 2. And since it's less than or equal to, it's going to be a solid line. Oops. Move that graph around a little bit. Okay, and since it's less than or equal to, I'm going to shade below that line. Now, if we look at this, our solution to this system is where all 3 colors cross. So what I'm going to do is I'm going to erase, because that's the easiest thing to do right here, is erase my shading. Don't erase your lines that you've drawn, but erase your shading where it does not all meet up. Okay. And that'll give us our solution, where I've kind of erased some of this a little bit. We can fill that back in. Okay. And then once we erase all of our pieces, we can get our solution. Okay. So this area right here, it's a little messy on mine, but you usually can use a highlighter or shade a little bit darker with your pencil to show the shaded area where all 3 colors cross, they lap over, is our solution to this system. Okay, so let's see another example of this. This one, we have to make sure we have to get each of these inequalities into slope-intercept form before we graph. So the first one is y is greater than negative x minus 3. The second one is y is less than 6x plus 1. And the very last one is y is greater than or equal to negative x plus 8. So let's graph each of these and then shade. So our first one is intercept of negative 3 and a negative slope of 1. And this is going to be a dashed line for us. Okay, so let's dash that line. Got a little off there. And then let's test the point 0, 0. Is 0 greater than negative 3? Absolutely yes. So we're going to shade in the direction of 0, 0. All right, now let's do the blue. Our y-intercept is at 1, and our slope is 6. 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. 2, 3, 4, 5, 6 over 1. And this is also going to be a dashed line. And let's test the point 0, 0. Is 0 less than 1? Yes, it is. So we're going to shade in the direction of the 0, 0. All right, now let's do our green inequality. Positive 8 is our y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. And a negative slope of 1. And that is going to be a solid line. Let's test our point 0, 0. Is 0 greater than or equal to 8? No, it is not, so we cannot shade in that direction. So we're going to shade in the opposite direction of 0, 0. I see where it overlaps, so I'm going to erase what doesn't. And like I said, you can use a highlighter if you want, if you don't want to erase, or just shade it a little bit darker with your pencil so it looks a little bit neater. And this little piece at the top does not belong to. So that little area, that kind of triangle kind of looking area in the upper right hand corner is our solution, because that is where all three colors overlap. Okay, I have one more graphing example to show you. Okay, so let's put it in slope-intercept form like usual. So we have a negative 1/2 y is greater than or equal to negative 2x plus 4. We're going to multiply by a negative 2 to everything to get rid of that fraction. And remember, when you multiply by a negative number or divide with an inequality, we have to flip that inequality sign. So we're going to get y is less than or equal to 4x minus 8 is our first inequality. Our next one is negative y is less than or equal to negative 4x plus 5. Multiply by a negative 1, so we flip the sign. So we get 4x minus 5. That's our second inequality. And our very last one is y is greater than or equal to negative x plus 10. I'm going to graph those three. So we get a negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And a slope of 4. 1, 2, 3, 4. And this is going to be a solid line. Test our point. Is 0 less than or equal to negative 8? No, so we cannot shade in that direction, so we shade to the opposite side. Okay, let's do our blue one. Our y-intercept is a -5, and our slope is 4. And this is also a solid line. These are really close up because they're parallel. And like I said, using a ruler makes these look much nicer. And let's check our point. Is 0 greater than or equal to -5? Yes, so we are going to shade in the direction of 0, 0. And our very last one, +10 is our y-intercept and a negative slope of 1. And this is going to be a solid line as well. Let's check our point. Is 0 greater than or equal to 10? No, so we have to shade in the opposite direction. And if you notice, there is not one area where all 3 colors overlap. So this is actually an example of a no solution, because we do not have an area where all 3 overlap. Okay. Next up, we can actually move backwards. We can look at the graph and we can write equations from each of these. Okay, so let's I'm going to name these. Let's call this F, G, and H, so you know which ones I'm going to be writing the equation for. Okay, so let's start with F. So if we look at this, we're going to be writing this in slope-intercept form. So if we look at this, the y-intercept is at 3, so we can write that down. Okay, so our y-intercept is 3, and our slope, if we go from point to point, we go from here, rise 1 over 1, 2, 3, 4. So it's y 1/4 x plus 3. And now we have to determine where we are shading for this one. Okay, and since if we're looking at this, it's shading above it, okay, and we can test our point 0, 0 to see if it's not a solution. Since it's shading in the opposite direction, oh wait, that one's going below. It's going in below because it's being shaded this way. So it is going in the direction of the 0, 0 for this one. We have to make sure the symbol matches for 0 being less than 3. So that's how you figure that out. That's going to be less than. Okay, let's do the next one. Okay, let's look at the G. Okay, the G also has a y-intercept of 3 and a slope of we're going to rise 2 over 1. So this is a -2x plus 3, and we're going to look at the symbol. Since it's being shaded in the opposite direction of 0, 0, we have to make sure 0 is not going to be a solution. So that's going to be greater than, because 0 is not greater than. We kind of have to do a reverse on that one. Okay, and the very last one, H. H, the y-intercept is at 1, 2, 3, 4, 5, 6, and the slope is up 2 over 1. And it is being shaded down here, so 0, 0 has to be a solution. So 0 is less than, so it's less than or equal to 6. Those are a little bit trickier, but once you get the hang of it, they're not that bad. All right, so that's an example of writing an equation from a graph.